All right, looking more at our basic trig functions, more specifically when we're looking at advanced trig. So the first thing you'll notice is this little weird thing right here. Okay, that represents your angle. So whenever you get into more advanced trig, which is where we're headed, we call our angles theta. Okay, theta is a Greek letter. It's like a O with a little extra curly thing through it. Kind of like pi is a Greek letter. We just use it to signify angles a lot. Okay. We also, as we get more into trig, we're talking about an actual x and y coordinate. So here's the x, here's the y. Okay. And so we call this side the x and this side the y. So we actually talk about it compared to the coordinate grid. R we use because this represents your radius. Okay. When we have our SOHCAHTOA stuff, it's still the same thing. You're still talking about adjacent over opposite and things like that. But we're going to call them different letters. So in this case, with this angle right here, or this one, the opposite is your y, adjacent is the x, the hypotenuse is r. So we represent sine of theta as y over the radius. And we represent cosine of theta as x over the radius. And we represent tangent as opposite over adjacent, or y over x. Okay? Again, this is just, it's the same stuff, just kind of presented in a different way. So right here, we just did these questions when you're finding sine of each one. So if we call, and we literally just did this, so I don't know if I'm going to do it again, but if this is theta, then this would be y, this would be x, this would be r. So I'm just going to do sine of theta equals, again, 5 over 13. Cosine of theta equals 12 over 13. And tangent of theta equals 5 over 12. Okay? We could do the same thing for the other angle, but I'm not going to because, again, we just did that. Okay? So down here, when you're solving for the missing part, okay, so first of all, I would notice that that's in degrees. So again, we just kind of did questions like this. I'm going to call this one y and this one x. If I want to find y, I'm going to use sine of 25 equals y over 14. Okay, this is your r. Okay, and when you do this, again, we're going to multiply by 14. So y is going to equal 14 times the sine of 25. And then when I'm finding x, I'm going to use cosine of 25 equals x over 14. Again, x equals 14 times the cosine of 25. Again, I can just plug those into my calculator, making sure I'm in the right mode, which I am. 14 times the sine of 25 is going to be 5.91, let's say 67. And 14 times the cosine of 25 is going to be 12.6883. Again, those are nothing different than what we just did. But what does get a little bit different is when we're looking at these word problems. Okay, I know how much you love word problems. So these are really good questions. We have a jet that's approaching the airport in Chicago, and it reads 5,900 feet as it passes directly over the Sears Tower. So this tells me that I'm 5,900 feet above the ground. Okay. At the same time, the angle of depression from the plane to the end of the runway is 5 degrees. So the thing is, you have to kind of understand what an angle of depression is. Sorry, that's a very straight line. Angle of depression is this right here. It tells me that is 5 degrees. Well, again, if you think back to geometry a little bit, this is your two horizontal lines are parallel. And when you have two parallel lines cut by a transversal, you have these alternate interior angles are equal. So this is also going to be 5 degrees. Okay, how far is it from the base of the Sears Tower to the end of the runway? So I'm looking for this side right here. I'm going to call it x. So again, I have to decide which of my trig functions uses these two sides. Well, this is your hypotenuse, so I'm going to have to do tangent. Tangent of 5 equals opposite over adjacent. Okay, again, to solve this is where you're going to multiply both sides by x to get the x out of the denominator. And then divide by tangent. X equals 5,900 divided by tangent of 5 degrees. Again, I can do that in my calculator. Divided by tangent of 5. It gives me x equals 67,437, let's say 0.3 feet to be exact. So these are very common trig functions. Here's another one. At 10 a.m. on April 26, 1998, because it matters how long ago was 1998, a building that's 300 feet high, I'm going to draw a building just because this is a 300 foot high, this is 300, okay, I won't label it up there, cast a shadow, so here's the shadow of the building, that is 50 feet long. Find the angle of elevation of the sun. So really, if you drew a picture, your sun is over here, and, well, I guess it's really up here. Who puts the sun on the ground? What a joke. And it's shining down here, right? And you want to know the angle of elevation. Well, that is going to be your angle right here. Is going to tell you the difference of that, the angle of elevation of the sun. Okay? So to figure that out, we're going to have to use one of our trig functions. And in this case, again, it's tangent because I have opposite and adjacent, and I don't care about my hypotenuse. So I know tangent of theta is going to equal opposite over adjacent. Okay. Well, you could simplify that. 300 divided by 50 is 6. So tangent of theta equals 6. If you want to find the actual degrees, you do what's called the tangent inverse. So theta is going to equal tangent to the -1 of 6. So that's what I do in my calculator. It is a second. So if you go second tangent, it brings up the tangent inverse of 6, and that'll tell you that this is going to be 80 degrees. You could put 0.5, I guess 80.5 degrees.